The electron configuration examples. You were asked to write the electron configuration for beryllium, nitrogen, sodium, chlorine, and one more, silver, which you don't see on this list, and I have removed it for a reason. But I do want you to write that. But here are the answers. Now, beryllium has 4 electrons, and the configuration would be 1s2 followed by 2s2. Remember that in the S subshell you can only have a max of 2 electrons, and for the principal energy level 1 there is only one subshell, which is S. After that we move on to the second subshell, and we must start with the lowest energy. We move on to the second principal level, the 2, and then we must start with the lowest subshell, which is S, and we fill it up with 2 electrons. Nitrogen has 7 electrons altogether: 1s2, 2s2, 2p3. So we end up with the second principal energy level with the p subshell having 3 electrons. Now, just to ask you, these 3 electrons, in which orbitals are they? Pause your video and think about it. The answer is there are 3 p orbitals, and 1 electron will go in each, and all 3 of them will go with the same spin. You show that by drawing the orbital diagram and having the 3 electrons point up in each. Sodium has 11 electrons: 1s2, 2s2, 2p6, and then 3s1. Why did we go to 3s1 after 2p6? Because in the second energy level, the principal energy level number 2, we can only have 2 subshells, which are S and P. In S we can have a max of 2 electrons. In P there are 3 orbitals with a max of 2 per orbital. We can have only 6. So then we go to the next orbital, the next energy level and the next subshell and the only orbital it possesses. Chlorine has 17 electrons, and the configuration is 1s2, 2s2, 2p6, 3s2, and 3p5. Now silver. Silver has 47 electrons. So there are going to be lots of electrons that would need to be placed in their locations. But more importantly, there are going to be exceptions to the filling order. We are not going to fill up all the principal energy levels starting with 1, 2, 3, 4, increasing like that. Instead, there are going to be exceptions, and it's very easy to figure out what the exceptions will be if we look at this chart. Keep 47 electrons in mind as we traverse through this chart or going through these arrows wherever it points. So 1s2, that's 2 electrons, 2s2, that's 4, 2p6, so that's 10, 3s2, 12, 3p6, 18, and then instead of 3d10 we have 4s2, that's 20, then 3d10, that's 30, 4p6, that is 36, 5s2, that's 38, and then 4d9, that will give us 47 electrons. So we stopped at 4d9. So if you make this chart, learn how to draw this for your exams, then you should be able to write the electron configuration for any atom. And all you need to do is remember that S has 2 max electrons, P has 6 max electrons, D has 10 max electrons, and F has 14, not shown here. Alright, now while the electron configurations, writing them completely is something that you should be able to do, we might prefer not to write them completely, and we'll come to this chart in a moment. But there is a shorthand method of writing electron configurations, also known as abbreviated configurations. For example, if you have the electron configuration of sodium, and here it is 1s2, 2s2, 2p6, 3s1. What we do is, if we go to the periodic table, sodium would be here. Instead of writing the configuration starting here and writing every little detail, we write in square brackets the symbol for the element, the noble gas that precedes the element that we are trying to write the configuration of. In sodium is here, our noble gas right before it must be here, which is neon. In square brackets we write down neon and then start writing the configuration at this point, which begins at 3s1. And so that method can be employed once we know how to write the configurations with ease, and in order to save time, we write the shorthand version of electron configurations. Write down the shorthand versions for these four elements: nitrogen, sulfur, titanium, and tin. Now coming back to this chart, what we have here, we have looked at the periodic table previously. It is very neatly organized and it packs a lot of information, and there is also information there that is not conveyed to you directly. The electron configuration information is one of it, and what you have here is known as the S block. All the group 1A elements fill up the configurations ending in S1. So you have 1s1, 2s1, 3s1, 4s1, 5s1, 6s1, 7s1. Try to write the electron configurations of these elements and you will see that for yourself. And in this portion, the group 2A, they end in S2. So you have 2s2, 3s2, 4s2, 5s2, 6s2 and 7s2. This is known as the D block. We fill up the 3D, 4D, 5D and 6D. Remember, there are 10 electrons in the d orbital because there are 5 orbitals in the d subshell. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, all the 10 electrons. This here is known as the p block. There can be 6 electrons in the 3 orbitals that the p subshell contains. 1, 2, 3, 4, 5, 6. The 2 p's, 2p1, 2p2, 2p3, 2p4, 2p5 and 2p6, and similarly all the way to 7p6. And the 2 periods that are removed from here contain the F block, and they are the 4Fs and the 5Fs. There are 14 electrons found in the 7 orbitals of the F subshells. So these are the first 14 for the 4f1 to the 4f14, and these are the second 14. So that is how we write the electron configurations of elements, how we write the shorthand configurations, and what do electron configurations have to do with the periodic table.